Okay, so today we're going to be talking about functions, continuing our conversation. And so far we've talked about functions being represented as tables, as a set of ordered pairs. We've talked about them as discrete graphs and continuous graphs. We've talked about them as a graph. We've talked about them as a map. But the one way that we have not talked about them yet is as an equation. And so functions can also be represented by an equation, okay, or a rule. Okay, an equation is really truthfully just a rule for a function. So what's going to happen is that when we have an equation or a rule, it's going to generate ordered pairs. Okay, and we've done a little bit with this without even realizing what we were doing a couple of weeks ago. And so what we do is we take an input, it's an x value, and it's going to give you a certain output or y value, okay? Where those are x and input is x and output is y. And so the graph is the set of all of the ordered pairs, and normally it's going to form a line or a curve. That's where we get that continuous graph. Remember, there can be an infinite number of inputs with the output and an infinite number of outputs as well, okay? And so this is kind of how you can think of it. It's a function is a machine or a rule. When you input an x value and you do what the rule tells you need to do to that x value, you get out a y value, and that x and that y go together to create an ordered pair, okay? And so we also call the x value not just the input, but sometimes it's called the independent variable because it's a number that we choose or is given to us, okay? And we call the y value the dependent variable because its value depends on whatever x value we put in, okay? So it's pretty simple so far. So here's what some examples are going to look like. So the rule is that if I take an x value and I add 4 to it, I'm going to get a new y value. So that's what I'm going to do. So I'm going to work mine out over here on the left. So I'm going to take each of these x values that were given, plug them in, and get a y value for them. And then we're going to graph it. Okay? So y is equal to, and instead of x, I'm going to plug in -5 plus 4, which gives us -1. And that's going to be the y value. So when I plug in -5, I get an output of -1. When I plug in -4 and add it to 4, I get an output of 0. When I input -2, I get an output of 2. And when I plug in 0, I get an output of 4. Okay? And so now I have 4 ordered pairs, and I can graph those and look and see what that function looks like. So -5, -1, -4, 0, -2, 2, and 0, 4. Okay. We're dealing here with a line. Sorry about that. My computer's getting emails. We create a line here, and this function is a line, so we can actually connect those points. It is a continuous graph, okay? So all we did was take those x values and we plugged them in and created or found the y value that matches, okay? So we're going to do the same thing down here for number 3. So this time the rule is if I have an x value and I multiply it by 3, that's where I'm going to get the y value from. So this time I've been given -2, -1, 0, and 1. So 3 times -2, all right, I'm going to take that -2 and plug it in. -2 times 3 is -6, that's the y value. If I plug in input to x value of -1, I get an output of -3. If I plug in an input of 0, I get an output of 0. And if I do an input of 1, I get an output of 3. And then I can graph that. So -2, -6, -1, -3, 0, 0, and 1, 3. And again, we have a straight line, and since it is a function, or it is an equation of a line, we can go ahead and make that a continuous graph. Because if I were to plug in if I were to plug in 2, I would get another point on that graph, and so on. If I plugged in 1/2, I would get a point that's already on that graph. So it is a continuous graph. All right. So now let's talk a little bit more about these. Here's another example, number 5. So in this case, okay, if I have an input value, I'm going to find the opposite of it, that negative, and then I'm going to add 1 to it. So here are my 4 input values. I have -3. So I have to be careful with this because I have a negative that's already a part of the rule. Then I'm going to plug in a -3 as my input to find the output. So a -3, the opposite of that, is actually a +3 plus 1 is 4. So the output on this is 4. And if you're unclear about what just happened with that, you can ask me about it. I'll be glad to help you with that. We input a -1. Opposite of that is a +1. Plus 1 is 2. So our output is 2. Here we input a 0. Well, the opposite of 0 is still 0. Add 1 and we get 1. So the output is 1. And here we input a 4. The opposite of 4 is a -4, and we add 1, and we're going to get a -3. Okay, and then we can graph that. So 1, 2, 3, 1, 2, 3, 4. There's our first point. There's our second point, third point, and our last point. And again, it makes a straight line. We could plug in all these additional points in between. All of them would show up to be on our line, and so we can connect that as an equation. Okay. All right, so that's all that we've done on this. So if we look at these bottom examples, we're going to continue to do the same process. We're going to skip down and do a few different ones. I'm actually going to skip to 11 and 13, so you guys will have a few more extra practice problems on your own. So it's given to you that you have a function and a domain, and it's asking you to find the range. Okay, so this one, we're not going to be graphing it. We're actually just going to find the range. So we're going to use the same process. I'm going to do an XY table. So I know that the inputs, the domain, are -4, 0, and 6. I'm going to solve for the Y values. So here we have 7 minus 1/2 times an input. That's the rule. So the input is -4 here. And when I multiply -4 times -2, I get a +2. And so 7 plus 2 is 9. That's going to be my Y value. If you want to plug that into a calculator, you can do that as well. That'll give you a +9. The second one, we have 7 minus 1/2 multiplied by a 0. And 7 minus 0 is 7. Okay. And then the last one we have is an input of 6, and when we multiply that out, we get a -3. 7 minus 3 is 4. Okay, and so we end up with a range. Okay, so notice that my domain came as a set of numbers, so I'm going to do my range also as a set of ordered pairs. Okay, sorry, as a set of range numbers. So I'm going to write them least to greatest, 4, 7, and 9. And that's going to be my final answer on this. All right. And then we're going to do number 13 together. We're going to plug in each of these values. So 7 minus 4 times, and again we're using -3 here. So I'm going to make my little table. And when I plug that in, I get 12 plus 7 is 19. And then here I'm going to plug in an input of -1. And 7 and 4 is 11. And then the last one I'm going to plug in a value of 5. And 7 minus 20 is -13. And so here are my range values. I'm going to rewrite it the way that my domain was given to me. And so I'm going to write at least to greatest, negative 13, 11, and 19, okay, as my final answer on that. Okay, so that's really all that we're doing on these. We're just plugging the values in, we're finding the correct y value, and we're either graphing it or rewriting it as a range, however it was given to us, okay, and whatever is asked of us to do. So you can continue to go ahead and work out the evens and number 7 and 9. Give you plenty of practice problems on that. Plenty of practice problems. You can do 2 and 4, 6, 8, 10, 12, 14, and then 7 and 9 are also there for you to work on as well. And if you have any questions, you can let me know.